Hello, everybody. This is a honors pre-calculus progress check review. We're going to be reviewing factoring, and we're going to be reviewing P problems, finding trig ratios or evaluating trig functions at different points. So I hope this video helps you review for the progress check a little bit. The capture sheet is in both the slide deck that's shared with you in my MCPS classroom, and it should also be embedded in this video description. So if you want to print this capture sheet out, feel free, or you can write on it, make a copy and write on it. Okay, so we're going to start with factoring. Part one will be factoring, and part two will be P problems. So we're going to start with part one. So we're going to practice factoring trinomials, and then we'll practice with differences of squares. So when we're factoring trinomials, just as a review, these are the 5 steps that are the most helpful to remember. First, if you have ax squared plus bx plus c, we're factoring a quadratic trinomial. Factor out the greatest common factor if there is one. Then we're going to find a times c, find the factors of a times c that will add up to b, rewrite the original expression by replacing the term b of x with the factors from step 4, and then factor the equation by grouping at the end. And then if we factored out a GCF in part 1, we have to multiply it back in part 5. None of these are going to have a GCF that you can factor out, so we don't really have to worry about that. But if you ever do find yourself with a GCF, you'll know what to do. Okay, so let's get started with an example. So we have 2x squared plus 3x plus 1, right? So we have our a is 2, b is 3, and our c is 1. So this is kind of how I like to just visualize my factoring, and you don't have to do this, but I like to visualize it that way. So a is 2, c is 1, 2 times 1 is 2. So a times c is 2, b is 3. So I just think about what are 2 numbers that are factors of a times c that will add up to b. So now we're in step 3. Okay, those 2 numbers, you can pause the video and think about it if you want. Those 2 numbers are 2 and 1. So I'll rewrite the original expression. So this is step 4 by splitting 3x up into 2x plus 1x. So I haven't changed the expression at all. I've just broken up the 3x into 2x and 1x. Okay. And then step 5, I factor the equation by grouping. So I have a set here and a set here, and I'm just going to factor out the greatest common factor between 2x squared and 2x. And then for this set, between 1x and 1. So what can I divide out of 2x squared and 2x? Well, I can divide out a 2, and I can also divide out an x. So let's go ahead and do that. We divide that out, and what are we left over? 2x squared divided by 2x would just be x, and then 2x divided by 2 would just be, or 2x divided by 2x would just be 1. And then I'll factor out a 1 here because that's all I can do. There's nothing else but a 1 to factor out. So 1x plus 1. And then I factor one more time. I basically factor out x plus 1 from both of these terms, x plus 1, and then multiply by 2x plus 1 because that's what I have left over. And that's it. And there's no step 5 because I didn't factor out a GCF at all. Okay, so I don't need to worry about that. And if you wanted to check your answer, you could FOIL it, right? Do the binomial distribution first, outside, inside, last, or if you like the lattice method, you can distribute it back together to check and make sure that it does in fact multiply back to 2x squared plus 3x plus 1. Okay, so now the second one, 3x squared, this is 3x squared plus 7x plus 2. All right, so I'm going to identify my a, b, and c. So my a, coefficient to x squared is 3, b is 7, c is 2. 3 times 2 is 6. So a times c is 6, and then b is 7. So you're welcome to pause the video at any time and try this whole problem by yourself if you want, or you can watch along with me. So what multiplies to 6 and adds to 7? 6 plus 1, or 6 times 1. So now we're going to go ahead and do so we've done step 1, 2, and 3. Now we're going to rewrite the original expression, step 4. So 3x squared plus 6x plus 1x plus 2. Okay, so now I have 4 terms, and I'm going to factor by grouping. So the greatest common factor of 3x squared and 6x has to be 3x, and then x plus 2 is left over. And then the greatest common factor between 1x and 2 is 1. So I have x plus 2 left over. And then I undistribute, factor out one more time that x plus 2, And then I'm left with 3x plus 1. And again, as before, you could distribute it back together to make sure you get this if you wanted to check your work. Okay. All right, now, why are we doing this again? We did it in the fall, you might be asking. So the reason we're practicing this again is because part of the next unit and next part of what we do with trigonometry involves being able to factor, to see certain things about an expression. So we can actually factor this just like we factored these. And one way you might want to do it is think about, instead of cosine of x, let's just let it equal something else. We'll make it another variable, say u, right? And then we can substitute the cosine of x back in later. So let's just rewrite this as 2u squared plus 5u plus 2. Okay, now it looks more like this. It's more like what we're used to. All right, so let's go ahead and apply the same procedures, right? There's no GCF, so we don't need to do step 1. A times C is 2 times 2, so that's 4. B is 5. What factors of 4 will add up to 5? Well, that would be 4 and 1. So we'll split the middle term, 2u squared plus 4u plus 1u plus 2, okay? Group and factor. So 2u comes out of this first set. U plus 2 is left inside when you divide 2u out. Now we can only factor out 1 from 1u plus 2, so that'll just be u plus 2. And we'll factor one more time, u plus 2 times 2u plus 1. And then we'll substitute cosine of x back in. So cosine of x plus 2 times 2 cosine of x plus 1. And that's our answer. And you can always, again, distribute it again just to make sure that you have it right. Okay, the column on the right should go a little bit more quickly because once you figure out the pattern, it goes pretty quickly. So let's say, so we have a squared minus b squared. So that's kind of like if you imagine you had a squared plus 0 plus c. So that's kind of like if your middle term is 0, then you can kind of skip all of these steps. And sorry, this should be b squared. You can skip all these middle steps and just factor them into their square roots. So if you have a difference of perfect squares, you can just factor them as the square root of a plus b, square root of a squared plus square root of b squared times square root of a squared minus square root of b squared. Okay. So, and if you think about it, it makes sense because if you multiply them back together, right, you do the double distribution, you have a squared plus negative ba, it's positive ba minus b squared. The negative ba and the positive ba will cancel, so you'll have a squared minus b squared, okay? So you're welcome to, again, pause the video at any point to try all of these. Or you can watch all the way through. So x squared minus 49, square root of 49 is 7, square root of x squared is x. So this is going to be x plus 7, x minus 7. Okay, b squared minus 25, square root of b squared is b, square root of 25 is 5. So it's going to be b plus 5, b minus 5. Z squared minus 16, square root of z is z, square root of 16 is 4. So z plus 4 times z minus 4. And then m squared minus n squared, m plus n, m minus n. Okay. And you might be asking, well, what if I write them the other way? What if I say x minus 7 times x plus 7? That's fine too, because remember, multiplication is what's called commutative. As long as these are the same two factors, you can write them in any order that you want. So that's fine. Okay. Sine squared theta minus cosine squared theta follows the same rule. Okay, square root of sine squared is just sine, square root of cosine squared is just cosine. So sine of theta plus cosine of theta times sine of theta minus cosine of theta is the factorization of this expression. Okay, it's the same rule, just like how we did the sort of substituting it with u and then putting cosine of x back in. It's the same deal, right? These are just terms. We don't have to be scared of them. And then the last one, cotangent squared of x minus cosecant squared of x, right? Feel free to pause the video and try that. But cotangent of x plus cosecant of x times cotangent of x minus cosecant of x. Okay, so same rules. All right. So that's factoring, and then a little bit of a taste of factoring with trig as well. Okay, so on the back, the second thing I want to review is what we call P problems. So I'm going to do one of each type. One type is if all we have is a point, x, y. And then the other one will be if all we have is a ratio, what the trig function is. So let's do this first one. Let theta be an angle in standard position with a terminal side that passes through point P at 1, 2. Find all 6 trig ratios. Okay, so this is a triangle that passes, it's in the coordinate plane. So we'll say we have x and y, and we have a point 1, 2, and that's where the angle will terminate, as a ray that passes through the point 1, 2. Okay. We need to draw a triangle, right? And you can pop the triangle out if you want to kind of get a better look at it. But you know you have an x length, like, you know, your horizontal length is 1 because x is 1. Then your vertical length is 2. So now we just need to use the Pythagorean theorem to figure out what r is supposed to be. So x squared plus y squared equals r squared because it's Pythagorean theorem. So 1 squared plus 2 squared equals r squared. So this will be 5 equals r squared. So square root of 5 is going to be r. So our r is the square root of 5. Right? So now we know all 3 side lengths of the triangle. We have x is 1, y is 2, and r is square root of 5. So now we just need to put these in the appropriate places for our trig ratios, right? Sine is y over r, cosine is x over r, tangent's y over x, cosecant is r over y, secant is r over x, and cotangent is x over y. So it's really just about substituting our values in at this point, right? So y over r would be 2 over root 5, or if you're rationalizing the denominator, 2 root 5 over 5. X over r would be 1 over square root of 5. And again, if you're rationalizing the denominator, it's root 5 over 5. Y over x is just 2 over 1, which is 2. And then we do our reciprocal trig function. So r over y will be root 5 over 2. R over x would be root 5 over 1, or we could just write that as root 5. And then x over y will be 1 over 2. So we have all 6 trig functions just by finding the radius or hypotenuse of the given triangle. Okay. All right, for the last piece here, what if all we have is a ratio? Well, we have to know what we're given. So let's say theta is an angle in quadrant 4 and cosine of theta is root 3 over 2. Okay, so let's sketch that out. So quadrant 4, we know we have 1, 2, 3, and 4, right? So cosine of theta is root 3 over 2. So what that means is that we have x over r, right? So we have x is, we can say root 3, and r is 2. X is root 3, r is 2. So now we just need to find y, and we can do that again, just like we did in the first part, by using the Pythagorean theorem. X squared plus y squared equals r squared. So root 3 squared plus y squared equals r squared. So 3, and this is, sorry, r is 2. I didn't substitute it in. This is a 2. So 3 plus y squared equals 4. Y squared equals 1. The square root of y squared is the square root of 1. And in this case, because we're in quadrant 4, it's going to be -1 because y is negative. We're below the x-axis. We're in quadrant 4. So we have a negative y. So we have, now we know all 3 of our triangle sides. Okay. And now we can just go forward from here using the same pattern that we had over on the left side with, you know, which side goes with which trig function. So remember, sine of theta is y over r. So that'll be -1/2, 1 over 2, -1 over 2. Tangent will be y over x, so that'll be -1 over √3 or -√3 over 3. Cosecant will be r over y, so that'll be 2 over -1 or -2. Secant will be r over x, so that's 2 over √3, which is the same as 2 √3 over 3. And then cotangent will be x over y, so that'll be √3 over -1, which is -√3. So those are all 5 of our trig functions, right? So these are kind of the 2 types of problems you've seen in this class, one where you have a point and then one where you have a ratio, but they're all doable. You just have to know what you're working with. Here you're working with x and y, you need to find r and then drop the appropriate values where they go. And then here you're given, you have to know what you're given. So if you're given cosine, you have x and r and you need to find y. If you're given another one of these trig functions, you have a different pair of sides of the triangle and you have to find your missing side and then fill in from there. Okay, so I hope this video helped you understand a little bit better both factoring and P problems, and enjoy, and good luck on your assignment and your progress check.